Good morning. Happy Thursday. Today is day 132, and our work today continues to focus on linear systems. Specifically, we're going to focus on how we solve these linear systems by using a method we call substitution. At this point, you already should have read through today's objectives and key terms, which we'll talk about briefly in a second. And then you already should have tried to complete today's exploratory problems working through with your partner. And at this point, you're analyzing your work with me by watching the video recap. A few things we'll point out about objectives today. Our work's really going to focus on objective 3 here, how to determine common solutions to a linear system by using substitution. If you're not sure what a linear system is yet or what a common solution is, I would encourage you to take some time to read through these two objectives and the key terms. Yesterday, as we started to focus on substitution really for the first time, we remembered that substitution is replacing a variable with a number that it's equal to. And today we're going to add to that definition and understand substitution could also be replacing a variable with an equivalent expression, something with numbers or variables that one of our other variables is equal to. If you think back to last year with Mr. Neville, this is kind of the plug part of what he referred to as plug and chug, where we would be replacing variables with a number, and again, today potentially an expression instead of just a number getting plugged in for a variable. So for part A today, or the first problem for exploratory problems, we were shown a linear system, two equations working together at the same time. And the linear system, first one in red is y equals 5. The second one is 2x minus y equals 7, and you see those on my whiteboard over here. Part 1 asked, based on the information provided by the red equation, do we already know part of the common solution for this linear system? And so again, they're referring to the red equation. If you take a look here, a common solution is going to be the values for x and y that work in both equations. And this first equation says y has to be 5. We don't have any other choice. If we're going to find a common solution to make the first equation true, we know the value for y is already known. That value happens to be y equals 5. So we really do know half of our linear system's common solution already once we know y equals 5. The second part asked us to use substitution as a strategy to determine any common solutions to the linear system. And now substitution should be reminding us that part of plug and chug, plugging in numbers or expressions for a variable. And here, if we know that y equals 5, we should be seeing something that can be done with the other equation, 2x minus y equals 7. So I'm going to put that whiteboard into full screen. And what we should recognize, if y is equal to 5, if we know that from our red equation originally, then that 5 can be plugged into the other equation, 2x minus y equals 7. So instead of saying minus y, we replace or substitute out the y and plug in a 5 in its place because we know y and 5 are equivalent based on the other equation. What's the big benefit to doing that? Now we see our equation goes from two variables, an x and a y, to only having x. We can now solve this equation for x. I'd add 5 to both sides. And hopefully if you see 2x equals 12, we recognize x equals 6. So at that point, if I see that my common solution is y is equal to 5, x is equal to 6, and we wrote it as an ordered pair on our document, 6 and 5, we'd also be able to check if this really is the common solution. We could plug in the 6 for x and the 5 for y. 2 times 6 over here, 2 times 6 minus y, which is going to be 5, has to equal 7. And we see that equation becomes, let me full screen this whiteboard for you. So again, here we're just checking our answer, 2x minus y has to equal 7. So we plugged in a 6 for x. We plugged in a 5 for y. 12 minus 5 really does give us 7. So we see that this common solution, 6 and 5, it certainly works in the first equation, just plugging in a 5 for y. And if we put in 6 and 5 into the other equation, it also works. That's why it's the common solution. So again, that was just a quick method to confirm at the end after we do all this work that your answer is correct. At this point, if you struggled with Part B, we'd ask you to pause the video and try to work through Part B with your partner now that we understand substitution a bit more. We're going to continue directly into Part B as this video is going. So here's our next linear system. The first equation is y equals 2x. We see that here. And the next equation in the linear system, 3x plus 2y equals 21, is up here in purple. The first part, part 1, says what information does the green equation, this first one, tell us about the y variable? And then it goes on to say, explain how that information could help us work with the purple equation to determine a common solution. So again, equations are just math statements. In this case, it says the value for y is equivalent or equal to 2 times whatever the value for x is. So one thing that I could say right away here is I know that y and 2x are terms that are equal to each other. That's all this is saying. And if I know that 2x is a term or an expression with the same value as y, we know from our definition of substitution at this point, we can also plug expressions in if they're equivalent to each other, replacing them in an equation. So in this case, I can understand from the purple equation, we're going to full screen the whiteboard now. If y has to be equal to 2x, in the purple equation, we could replace the y with the 2x. So that purple equation could become 3x plus 2, but instead of times by y, now it's times by 2x equals 21. And again, all we did here was we substituted the y, which was multiplied with 2, and replaced it with 2x. Now it's 2 times 2x. And that's because of the information in the first statement, knowing y is equal to 2x. Why was that helpful? This is still a pretty complicated equation, but now instead of having two different variables, x's and y's, it has all x's. We could solve this equation for x. So hopefully once you see that, you could work through solving this equation. 2 times 2x gives us positive 4x. So the left expression becomes 3x plus 4x equals 21. We could combine those like terms. That becomes 7x equals 21. And if you're not able to solve by inspection here, you could divide both sides by 7. That would help us see 3 is the number that when we multiply by 7 gives us 21. So we see the first half of our common solution. We now know for our common solution here that x has to be 3. We still need to find the y value for our common solution. But now that we know x is 3, we could go use this simple equation y will be equal to 2 times whatever x is. And substitute the x and replace it with 3 now that we know that x is equal to 3. This tells us pretty quickly that y has to be equal to 6. 2 times 3 gives us 6. And if you want to confirm that my answer, x is 3, y is 6, really is the common solution, common solution here, you can go ahead and plug it into this purple equation, which says 3x plus 2y equals 21, and see if this works in the purple equation just like it works in the green equation. Thanks for watching the end of the video. You're going to continue to solve more linear systems that get a little bit trickier. Feel free to work with your partner. Ask me or Miss Stewart or Mr. Chu for help when you need it.